Hello, welcome to Unit 3. We've conquered differentiation, we know how it works, and now we're going to actually start applying differentiation. So you remember the last thing that we learned in Unit 2 was implicit differentiation, and I want to talk about that more and start applying it to some problems. Well, the derivative, known as dy over dx, is a function's instantaneous rate of change, right? It's the change of y with respect to x. And if a function describes a position or distance, then the rate of change is interpreted as velocity, and we're going to talk about that more in the next lesson. But until then, we're going to use implicit differentiation to solve the rate of change of kind of like a word problem. So we'll dive into it and you'll kind of see it in action here. But here, suppose x and y are both differentiable functions of t and are related by the equation y equals x squared minus 3x. We want to find dy dt when x equals 3, given that dx dt equals 2 when x is equal to 3. Well, we can do this pretty simply. This is just using implicit differentiation with respect to t this time. So we have y equals x squared minus 3x, and we want to find the derivative of this with respect to t. So the derivative of y with respect to t is equal to the derivative with respect to t of x squared minus 3x. Well, we can find that derivative. So dy over dt, can you still see this? Is it in camera? Yeah, I think so. Is equal to, well, the derivative here is going to be 2x times dx over dt minus 3 times dx over dt. You'll notice that what's different about this as opposed to implicit differentiation before is that before, when we were using implicit differentiation, we had dx over dx, and we didn't write that. We just wrote that as 1, or we didn't write it at all because it was already understood. But now, because we're differentiation with respect to t, we need to actually have dx over dt. So dy over dt is equal to 2x minus 3 times dx over dt. Well, now we were actually asked, we found our function, we found dy over dt, but we're supposed to find that when x equals 3, given that dx dt equals 2 when x equals 3. So we can say, I'll go up here a little bit, that dy over dt when x equals 3 is going to be equal to 2 times 3 minus 3 times dx dt we were given as 2. So that's going to be equal to 6 minus 3 times 2, which of course equals 3 times 2, which equals 6. So dy over dt when x equals 3 is equal to 6. And that's our final answer. We found the derivative with respect to t of that problem. So let's actually apply this a little bit more now and do something a bit more involved. I'm going to pause 1 second. Okay, I wanted to get a new pen because I think the green pen's running out of ink, and I wanted to switch to blue. I bought a new one. All right. So a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the disturbed water changing? Well, I'm going to write down a few things here. We know that the area of a circle is equal to pi r squared, right? You probably have that memorized from the past. And we're given that the radius is changing at a rate, when the radius is 4 feet, it's changing at a rate of 1 foot per second. So dr over dt, the change of the radius with respect to time, is equal to 1 foot per second. And we're asked to find, we want to find the rate of, what rate is the total area of the water changing? So we're asked to find dA over dt, right? At r equals 4 feet. That was actually given to us. So we're going to find dA over dt. We can take A equals pi r squared, and we're going to use implicit differentiation. So dA over dt is equal to 2 pi r times dr over dt, right? So dA over dt. Look at, I can't simplify that anymore. I can actually just solve this now. When r is equal to 4 is going to be equal to 2 times pi times 4 times 1, which is going to be equal to 8 pi. And because this is area, I need to actually label this. I need to label this. And this is important to remember. If you do not label on the AP Calc exam, you can lose points. So you can sometimes get 1 point purely for just labeling your information. So I need to write 8 pi, so dA over dt is equal to 8 pi feet squared per second, right? Because I'm talking about area, so it should be feet squared. All right, let's do another example. I have quite a few examples of these problems because I think that they're something that, you know, the more you see them, the more you get used to them. So air is being pumped into a spherical balloon at a rate of 800 cubic centimeters per minute. How fast is the radius of the balloon changing at the instant the radius is 30 centimeters? Well, we know, and maybe you don't know this one, but I'll tell you anyways, the volume, right? We're talking about cubic centimeters, so we're talking about volume of a sphere is 4/3 pi r cubed. I always liked that formula because I always thought it was a little different. Get you back in focus here. Okay, pi r cubed. And we're given that the air is being pumped in at a rate of 800 cubic centimeters per minute. So that's actually the volume, the change of the volume with respect to time is equal to 800 centimeters cubed per minute. And we want to find the radius. How fast is the radius changing? So we want to find dr over dt when r is equal to 30 centimeters. So we're going to use implicit differentiation again. So v is equal to 4/3 pi r cubed. So dv over dt is equal to, well, 12 divided by 3 is going to be 4 pi r squared times dr over dt. Now, we actually are solving for dr over dt, so we need to kind of get some things shifted around here. So I should, if I substitute in, I'm going to have 800 is equal to 4 pi times 30 squared times dr over dt. So 800 is equal to 4 pi times 900 times dr over dt. Oops. So 800 is equal to 3600 pi times dr over dt. If I divide 800 divided by 3600, I did it on a calculator, but anyway, it's 2 over 9 pi is equal to dr over dt. And I'm not done with this. I need to rewrite it. I need to say that dr over dt is equal to 2 over 9 pi centimeters per minute, right? We're talking about the change of the radius. The radius is in centimeters, so it's changing centimeters per minute. I have to have the label there, otherwise I would get that, I would not earn that point fully on the AP exam. All right, let's do another one. Got, I think, 4 more to go through. Yep. So, kind of a long video, but hopefully you can stick through it, or just watch it sped up, I don't care. The top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? Now, I'll tell you, I've seen problems like this in calculus time and time and time again. A lot of times with a problem like this, I find it easiest to draw it out a little bit. So I've got a wall there, and I've got a ladder against that wall, okay? So the ladder's 25 feet. It's sliding down a vertical wall at a constant rate. Well, you can see here that I've got a right triangle. So I'm going to call this my y, my x, just lining up with my axes. And I know that a right triangle is x squared plus y squared equals z squared, or, you know, whatever you want to say. A squared plus b squared equals c squared. You can do it however you want. We're given that it's sliding down at a constant rate of 3 feet per minute. So dy over dt, because this is sliding down here, is equal to negative 3 feet per minute. And I said negative because it's going down. That negative indicates direction. And we want to find when the top of the ladder is 7 feet from the ground. So we're trying to find when x equals 7, what's the rate of change of the distance between the bottom of the ladder and the wall? We want to find the rate of change here. So we're trying to find dx over dt when x is equal to 7. Okay, so actually we have our value here for z, it's 25. So I'm going to say that x squared plus y squared is equal to 25. And I use that implicit differentiation. So 2x times dx over dt plus 2y times dy over dt is equal to 0. Nice and easy. Well, 2, so we're trying to find this when x is equal to 7. So I'm going to substitute in here. I have 2 times 7 dx over dt plus 2 times y. Ooh, 1 second here. All right, so I forgot to square this, but honestly, that doesn't really matter. It still becomes 0 anyway. So 2 times 7 times 2 times y, and actually, I'm not even going to put this 7 in here yet. I'm going to come back to that. So I'm just going to solve here for dx over dt and kind of get this simplified. So dx over dt is going to be equal to, well, we're going to have, this would subtract, right? And then we're going to divide, so we're going to, and 2's will cancel out. So we'll have negative y over x times dy over dt. Well, we need to know, we have what dy over dt is, and we have what x is, but we need to know what y is. So we're going to use back to this original formula. Hopefully you can still see here. So I'm going to have x squared, so I'm going to have 49 plus y squared is equal to 25 squared is, I really should have this memorized, 625. So minus 49 is y is squared is equal to 576. Second square root of that is equal to y is equal to 24. So now I have that y is equal to 24 feet. So I can go back to finding this. So dx over dt is equal to a negative 24 over 7 times dy over dt is negative 3. So negative 24 divided by 7 times negative 3, I get 72 over 7 feet per minute. Now I'm going to pause this 1 second because I think I made a mistake and I want to check it. Okay, I did make a mistake and I found it. The top of the ladder is 7 feet from the ground. That should be my y value. So this should be a y, and that doesn't really change too much, but it does change a little bit, mostly with my final answer here. So let's fix that. Here, this, I can just change all of these to x's. So x is equal to 24. So now we have negative, y was 7, negative 7 over 24 times negative 3. So that's going to equal a positive 21 over 24, right? Which simplifies down to 7/8. Good, that looks a lot better. 7/8 feet per minute. Okay. Sorry for the confusion on that problem. I'm going to stop this video and then I'll upload 2 for this lesson. It is kind of a little more complicated and I want you to be able to get it all in. All right.